Okay, so now we're going to start looking at factoring trinomials. So we're going to start with trinomials that have a leading coefficient of 1. So looking back at what we've done already, before we've had factors like the following, where we have an x plus a times an x plus b, and we wanted to expand this, so we wanted to multiply these two things together. And we know how to do that using a couple of techniques. One of them is just the basic distributive property, but now we know that we can also use this foiling procedure. And so if we FOIL these out, we'll multiply these two terms and get x squared, and we can multiply a and x to get ax, multiply x and b, get bx, and then the last two terms ab, which we can rewrite as x squared plus we can combine these two terms together, so we have a coefficient of a plus b times x, and then this constant term is still ab. So the factoring procedures, we want to do this in reverse. We want to be able to be given this expression, and we want to factor it into these two products here. So what is the goal here? Well, the goal is you want to find a and b. But if you look at this, this expansion has produced a really nice pattern. Notice that the expansion of this product, we're getting this, so we know that the factoring of this trinomial will result in this factor. So what do we see? Well, if we need to find a and b, right, b as well, so find a and b, we want to find an a and a b that has the property of whatever the coefficient of x is, that'll be given, a plus b should be that coefficient. So a plus b is the coefficient of x, and ab, the product, will be the constant term. So ab is the constant term. So let's look at this first example here. We have x squared minus 7x plus 12. So the leading coefficient, which is the coefficient of x squared, is a 1. So we can proceed using this this factoring procedure over here. So we're going to factor into the following form, right? The goal is to get this. We want this to factor as x plus a times x plus b. Okay? But using this procedure, we need to find our a and b. Okay, so how do we do that? Well, we want to find an a and a b, find a and b, so that their sum is this coefficient of x, which is negative 7, and product is positive 12. And what integers work for that? Well, the integers negative 4 and negative 3 work, right? The sum of negative 4 and negative 3 is negative 7, and the product of negative 4 and negative 3 is positive 12. So this means that our a is negative 4 and b is negative 3, so we have that factorization. So x minus 4, x minus 3. So that would be our factorization. One thing I'll just add real quick, it wouldn't actually matter if I put the negative 3 here and the negative 4 there. It would still satisfy the condition that the sum is negative 7 and the product is positive 12. So the next example, trinomial has a leading coefficient of 1. The coefficient of x squared is still 1, so we can still use this same trick. We're going to eventually get a factor that looks like this, x plus a times x plus b, but we got to find a and b. So find a and b. So their sum is what? Well, the coefficient of x in this case is positive 1, and product is negative 12. So keep in mind that you have to pay attention to the signs here. That's included. And what solution works for this? A good thing to look at is the products, right? So the product is negative 12. That limits the types of factors that you can actually have, right? So if we're getting a product of a negative, then one of the numbers would need to be positive and the other one would need to be negative. And what are some factors of 12? Well, we have 1, 2, 3, 4, 6, and 12, right? So are any of those factors in pairs going to be a solution to this summation? Well, what I would consider are ones that are close together because we want the sum to be 1. So, for example, if one of them is 4 and the other is 3 and they're opposite in sign, then that sum might be positive 1. So can you think of the solution in this case? So the integers plus 4 and negative 3 look like they work, right? Because again, first, the way that I kind of am looking at these is to look at the product first, and that'll limit the types of factors that you can actually have, right? So positive 4 times negative 3 is negative 12, and the sum of those two is plus 1. So it's better to look at the product first in a lot of these. Think about all the factors, and then pick factors that'll make the sum condition work out. And so these two will work. So our answer will be x squared plus x minus 12 is equal to x plus 4 times x minus 3. Our next example still has a leading coefficient of 1, but the other coefficients have this other variable of y in them. However, we can still use the same procedure that we've actually been using before. So let's say that we want to factor this as x plus a times x plus b, right? Wrote b first, x plus b. Okay, so how do we do this? Well, what are the conditions? We must find a and b so that their sum is negative 5y. That would actually be the coefficient of x, right? So rewriting this is x squared minus 5y times x. So this is the coefficient, and minus 24y squared, that's the constant term. So I just wanted to rewrite it like this so you could see that the coefficient of x is negative 5y, and the product is negative 24y squared. So if a plus b is going to be this, right? This is going to be a plus b, and this over here is going to be a times b. It looks like a is going to have a y in it, and b is going to have a y in it for us to multiply and get this y squared. So kind of ignoring that portion of it for just a second, look at the coefficient of the y squared. We have this negative 24. So think about the factors of 24, or rather negative 24, and how are we going to get negative 5 in the end? So 24 has quite a few factors, right? So we have 1, 2, 3, 4, 6, 8, 12, and 24. So you got to think about those factors that I've listed, and they essentially have to be a distance of 5 apart, right? So which ones are those? So it looks like it would be 8 and 3, right? So 8 and 3 are a distance of 5 apart. And if I'm getting a negative here, what do we know is happening in the factorization? We know that one of these is going to be negative and one is a positive, right? So it looks like it looks like so what did we say? If we're getting negative 5, then the larger factor has to be negative. So negative 8y and positive 3y will work. Okay, now let's just see if those two actually work. So if I add these two, then adding the coefficients, we'd get negative 5, so negative 5y. And the product would be negative 8 times 3, which is negative 24, and then y times y is y squared. So this is definitely the solution. But let me remind you how I thought of this. Well, looking back over here at this coefficient of negative 24, think about all the factors that you're making. And if the sum is going to give us this coefficient of negative 5, then those factors have to be a distance of 5 apart in order for that sum to be possible. So I just started thinking about the factors and which ones are distance 5 apart, and we'll multiply and give us 24, and these are the ones, right? I mean, the factors come in pairs, right? So the factors of 24, there's quite a few of them, but they come in pairs, right? In the sense that how do you multiply and get 24? Well, you could do 1 times 24, you could do 2 times 12, you can do 3 times 8, you can do 4 times 6, and are there any others? Well, no, it would have to be something in between these two, but the only thing in between those two is 5, right? But 5 times 5 is 25, not 24. So you see that these come in pairs to give us 24. And so what I was kind of saying is this is going to be the correct pair, the 3 and the 8, because their sum is not 5, but the distance between them is 5. So if one of them is negative and the other one's positive, then when I add them, I can possibly make this correct coefficient there. So I'm just trying to give you, the idea of how you're doing this, but it's a little bit of trial and error, but it's still systematic in the sense that you are limiting your possibilities. Okay, so these will work, and we still can make one of those A and one of those B. So the factorization is or you could just say it's the solution. X, we could call that one A. It doesn't really matter if that's A or that's A. X minus 8y times x plus 3y. Now, if you're not convinced that that's true, you can always check your solution, right? You can always check and FOIL this out, right? So first two terms, x squared, then we'll have plus 3xy, and then minus 8xy, and then minus so negative 8y times 3y is negative 24y squared. And then these are like terms, so they will combine together, the coefficients combine, and we'll get negative 5. So we'll have x squared minus 5xy minus 24y squared. And is that what we originally had? So x squared minus 5xy minus 24y squared. That looks good. So you see, you can always, the nice thing about factoring is, yes, a lot of times it's a little bit of trial and error, but the nice thing is you can always check your solution. It's always reversible. It's usually always much easier to do the multiplication than to do the factorization, and that's always going to be the case. All right, but later on we'll see that this factorization process is very powerful for solving equations and all sorts of other techniques. It'll be very useful. So in our next example, we also have a leading coefficient of 1, so we can continue to use our same procedure and try to factor this. So it'll be x plus, well, you notice that this has some b's in it. All right, so just to kind of avoid some confusion, let's do x plus a and x plus c instead of a b, since the b is here and that's not going to be the same b as that's what's there, right? It's x plus something, and we got to figure out what those two things are. So what do we want? We want the sum a plus b to be equal to the coefficient of x. So what is the coefficient of x here? So rewriting this is x squared plus 10bx. So that right there is the coefficient of x plus, and then this whole thing is your constant term, 25b squared. So that's the constant with the plus term. It's important to keep track of that sign because that's going to be important. So we want the sum of a plus, we said that this is c, right? So the sum a plus c to be equal to that coefficient 10b, and the product ac to be equal to the 25b squared. All right, so we do have this extra variable floating around, but if you think about this, if a times c is going to be 25b squared, then each of them is going to have a b in it, right? So we know a equals something b and c equals something b is going to work, because when I multiply these two together, that's how I'm going to get this b squared. So now we have to fill in these blanks. So the coefficient of the b squared is 25, and luckily the factors of 25, there aren't very many, okay? You can either do 1 times 25, or we can do 5 times 5, which is 25, right? The factorization of 25 is 5 squared. So there's not very many choices, which is good. If there are a few factors, then that makes your life easier. That means that there's less possibilities for your factorization, okay? So it's very good. So what are we filling in with these blanks? Well, that's determined essentially by this sum up here. We know that the sum is going to be 10b. So we have something b plus something b is going to be 10b. Everything's positive. So what does it look like over here? Is it going to be 1 and 25? Well, no, because that sum is 26. But 5 plus 5 is definitely 10. So 5 and 5 are going to work for us, right? So this works, right? 5b plus 5b is 10b. 5b times 5b is 25. Okay? So the solution is x plus our a, 5b, x plus 5b. So that's correct. We could also write it even nicer. We could actually write this as x plus 5b quantity squared. That's even nicer, right? So that's good. Now moving on to examples that do not have a leading coefficient of a 1. So here the leading coefficient is a 2. All right. So we are no longer going to have x plus something and x plus something. Well, what are we going to have? Well, when you do this foiling process out, right, you're going to multiply the first two terms. And the multiplication of those first two terms determines this leading term, doesn't it? So how do we get 2x squared? Well, I can't just have x and x here, because if I FOIL this, then I will just get x squared, right? So how do I get a 2x squared? Well, I'm going to have to make one of these coefficients a 2x, or well, one of these coefficients a 2, but the term will be a 2x. So now 2x times x is 2x squared. Okay, so this is the slight difference between what we were doing before. So now we're going to have 2x plus something and x plus something. And we have to fill in these blanks. So we need to find these, right? Find this. Okay, now here's where you need to do some sort of trial and error, because we no longer can just follow the basic procedure that we actually had before, because now that we have this 2 here, when we do this foiling, this 2x is actually going to multiply this. So if I just called it b, yes, you could do that, and then you could say, okay, now I need to satisfy these two equations. But here's where trial and error can kind of help us out a little bit. What are we going to put there? Well, one thing we definitely know is when you do this foiling procedure, The terms that may simplify a little bit are the middle terms, right? Those are the ones that may combine together. But the leading coefficient, leading term, is determined by what we put in these two places, and the constant term is determined by what we put in these two places by multiplication. So find this, okay? So their product is negative 15, and by trial and error, find the pair that makes the sum work. Okay, so let's do some trial and error. So 2x plus blank, x times x plus something, right? So 2 plus something times x plus something. Okay, now we need to make the product negative 15. So what are some possibilities? So factors of 15, Now, this is a negative, right? So in the end, we actually know one of them is going to be a negative and one of them is going to be a positive, and we have to figure that out, right? So factors of 15, 1 and 15, 1 times 15, right? What else do we have? Well, 3 and 5. Anything else? Well, we could reverse these orders as well, right? I could put the 5 here, and I could put the 3 there, or 15 there and a 1 there, right? Okay, now we know one of them is going to be negative and one is going to be positive, since this is a negative 15, right? So we have to figure that out. Now, by trial and error, you're going to select what to put in here. So what are the possibilities that we can actually have? You know what? So let me erase this for just a second, and let's start writing this in. So what are some possibilities? Right? We're either going to have 2x plus something and x minus something, or we're going to have 2x minus something and x plus something, right? These are the possibilities, and then we can fill in these factors here. Okay, so what are we getting here? So with factors, the possibilities are the following. So we could have 2x plus 1, x minus 15. We could have 2x plus 3, x minus 5. We could have 2x plus 15, x minus 1. So I'm just kind of going through all these pairs that we just determined. 3x plus 5, x minus 3. Okay, and now we're just going to eliminate them one by one. Some of them you can eliminate quicker than others, right? So right now, if you look at this, the first and the last terms are fine for all of them, right? 2x times x is going to give us 2x squared for all these, and the product of the last two is minus 15 for all these possibilities. But when you start to expand them out, the middle terms are going to be incorrect. So for example, the middle terms, what are we getting? So we're getting 2x squared, then minus 30x plus x minus 15. So already, look at that middle term. That middle term is not going to match this middle term of negative x. So this one, right away, without even simplifying anymore, we just know that that's not going to work. Okay? And just kind of eyeballing this after a while, you'll get pretty good at just saying, no, that's definitely not going to work, starting to just write out these possibilities. So we are doing some trial and error here, but I'm sort of going a little overboard and showing you all the work that would go into actually verifying these things. So we'll have 2x squared. In fact, you could actually just write out and say, well, what are the middle terms? We already know that the first and the last terms are all correct for all these. Like they're all 2x squared and then minus 15, minus 15, minus 15, right? We're trying to figure out, is that middle stuff, is that correct, the middle terms? So what are we getting here? We're getting minus 15x and then plus 3x. But what's the sum of those? Well, up here, that was minus 29x. Here, that's minus, 12x, but still that's not minus x. So that one's eliminated as well. Let's cross that one off the possibility list. What's next? So we have minus 2x, right? Minus 2x, and then plus 15x. So now that's positive 13x. That's eliminated. And at this point, it looks like we already have nailed down the solution, but it's good to just check that anyway. Let's see if that one works. So we will have minus 6x and plus 5x. And yes, that looks like it is our solution. Whoops, minus 6x plus 5x is the minus x, right? Because minus 6 plus 5 is minus 1. So minus x minus 15. So this is the correct factorization right here. And this is sort of how the trial and error method is going to work for us when we're dealing with situations where the leading coefficient is not a 1, right? And so we're going to have to do a little bit more work there. But in a lot of cases, you could do this trial and error method, and it might not be so bad. Again, you're not going to have to show me all this work, right? When you're doing this factorization, you just need to produce the solution. So you can show as much or as little work as you want. Showing me all this extra work could be a good idea because I can give you some partial credit for showing me your method of solution. But in the end, a lot of times you're going to get pretty good at eliminating things pretty quickly. So how do we deal with situations like this? Well, now we have 3 plus 2x minus x squared. So even if I rewrote those, right, even if I rewrote this so it is minus x squared plus 2x plus 3, you could write it sort of in descending order like this. The coefficient of x squared is still not a 1. Okay, so you're still going to have to do a trial and error method. All right, so let's just stick to not rewriting that and seeing if we can get used to solving some of these things without actually doing that. So by trial and error, how do we simplify this kind of expression? So if we want to factor this, then and we want to get a 3 in the first term, how do we do that? Well, we would have to multiply two things and get 3. Well, 3 is a prime number, so it only has 1 and itself as a factor. So I have to have a 3 and I have to have a 1 there, right? A 3 and a 1, so that when I do this product, I get a 3. Okay? So the leading term is determined by those two. How do we get a negative x? So to get a negative x squared, the last two terms must be what? Well, I have very few things that can give me negative x squared as a product, right? Negative x squared is equal to negative x times x, which is equal to x times negative x. So what that means, so they must be either negative x and x or x and negative x. So what are your possibilities? So your possibilities are 3 plus x, 1 minus x, 3 minus x, 1 plus x. right? The only way to get negative x squared is to have one of them as a negative x and the other one as an x. So now we just have to figure out which one actually works, right? So here we have very few possibilities actually. So foiling this out, we'll have 3, our first product, and then negative 3x, and then plus x, and then minus x squared. So again, we already know that that term, the first term and the last term, are correct just by this trial and error. It's the middle term that we're trying to figure out. What is the middle term here? So that would be minus 2x. So this is 3 minus 2x minus x squared. And does that match what we originally had? No. We want a plus 2x, not a negative 2x. So that one is eliminated. That's not good, right? That one's gone. So now let's see if the other one worked. So if it doesn't work, then that means you did something wrong. So you would just kind of backtrack and see what you need to fix here. So 3, and then 3x plus 3x, and then minus x, and then again minus x squared. We have rigged it so far that the first and last term are definitely correct. It's really the middle terms that we're trying to figure out, are these correct? And simplifying, we did get plus 2x. So that's good. So that means this is our factorization. Okay, now going on, we have a squared plus 3ab minus 18b squared. Well, in this expression, the coefficient of our leading term actually is a 1. So we could actually do this either way. We could do this the original method, which would be, we know that we're going to have an a and an a, and then plus, I could call this c, and plus a d. And we want the sum c plus d to be equal to that middle term, the 3ab, and their product, c times d, is equal to this last thing, negative 18b squared. The reason I have to use c and d is because I was used to using a and b, but both of those are taken right now. So I had to, assign some new letters. So how do we get c times d equal to negative 18b squared? All right. What are the factors of negative 18? Well, the factors of 18, we have 1 and 18, we have 2 and 9, and we have 3 and 6. And are there anything in between those that evenly go into 18? Well, they would have to be either 4 and 5, and neither of those go into 18. So looks like these are the short list of possibilities that we have. Since the product is negative 18, one of these will have to be negative and the other will be positive. And which ones are going to give us a 3? Well, which ones are 3 apart from each other? It looks like 3 and 6, right? These two are 7 apart from each other, and these are 17 apart from each other. So it doesn't look like we're going to be able to produce a 3 with any other factors. So if we want positive 3, then that means we want to give 6 the positive and the 3 the negative, so that when we add them, we'll get 3. Okay, so how about I just say, it looks like C equals the positive 6b and D equal the negative 3b will work. And we can check that. Okay, so let's write that out. So we'll have a plus 6b, a minus 3b. So hopefully that's correct, right? We want that to be correct. So foiling this, we'll have a squared, and then we would have minus 3ab, and then plus 6ab, and then minus 18b squared. And then simplifying this a little bit more, a squared, and then plus 3ab, and then minus 18b squared. Now, is that what we had? So a squared plus 3ab minus 18b squared. Good. So that is the correct answer. Now, I just left a little bit of space over here because you could also have attempted this by trial and error. So solution 2, you could try this by trial and error, and you would say, okay, well, I want the first term to be an a, so I know that it's going to look like this and this, right? Then looking at the last term, I'm trying to get negative 18b squared. So one of these will be positive and one of these will be negative, okay? And how do we do that? Well, what are the possibilities for negative 18b squared? So to get negative 18b squared, what could we use? Well, one of them is going to have to be negative and one of them is going to have to be positive. And it looks like we could, we're going to end up looking at the factors of 18 again, right? So 1 and 18, 2 and 9, and 3 and 6. And we can sort of slowly go through this. One of them is going to be negative, one of them is going to be positive, right? So you're going to have a plus something, and then a minus something. So possibilities. You could have a plus 1, a minus 18, a plus 2, a minus 9, a plus 3, a minus 6, or now putting the negatives with the first factor, you could have a minus 1, a plus 18, a minus 2, a plus 9, a minus 3, a plus 6. So just looking at this real quick, you can see that the first and the last terms are going to match up as long as we put the b's in here, right? So the only thing missing is the b's. 6b, 9b, 8b, 6b, 9b, 8b. So just eyeballing this, we can see the first term is definitely correct. We're getting a squared for all of them. And the last term, we should be getting negative 18b squared. So 1b times negative 18b is negative 18b squared, negative 18b squared, negative 18b squared, negative 18b squared, negative 18. So it looks good. No other possibilities. And then you can sort of systematically check which ones will work and which ones won't. And you'll only get the solution that's a minus 3b, a plus 6b. So this is the only one that's going to actually work. The other ones you would have to reject by trial and error. So you see, this is a situation where there are quite a few possibilities. All right, so sometimes it can be a little bit tedious, but you can sort of slowly eliminate the possibilities. I think this one is a little easier to follow, this formal logic versus the trial and error, but that is always an option. So solution 2, you still got the same exact thing by trial and error, but it's sort of personal preference which one you think will give you the most optimum solution. And finally, we have this example here. So what are we going to have? So the leading term is a 2, and how do you make 2? Well, that's a prime, so the only way to do that is to have a 2 and a 1. How do we make a positive 6a squared? Well, it's positive, so 1 is positive and 1 is positive. I guess you could theoretically have both as negative, and since the middle term is a negative, we're going to have to investigate that possibility. Both of them are going to, in the end, have to be negative for that to work, right? So these will both have to actually be negatives. And let's look at how to make how to make a 6a squared. So we want the product as 6a squared. So what are the possibilities? Possibilities. So we could have a negative 6a and a negative a, right? That product will be 6a squared. We could have negative 3a and a negative 2a. And are there any other possibilities? Well, we also have to take into account the fact that this is a 2 and this is a 1. So we are going to have to also consider the interchanging of these possibilities. So negative a, negative 6a, negative 2a, negative 3a. Right? If the leading terms were both the same, we wouldn't need to consider the reverse of these. Like this negative 6a, negative a would be the same as negative a, negative 6a. But since we have to consider both possibilities, those are going to give us distinct answers in the end, right? So those are the only possibilities, right? Because the factors of 6 are 2 and 3. So the factorization of it is 2 times 3. So the factors would be 1, 2, 3, and 6. Okay, and here are all the possibilities. So the possibilities are considering all of these in there. So we'll have 2 minus 6a, 1 minus a, 2 minus 3a, 1 minus 2a, 2 minus a, 1 minus 6a, and then finally 2 minus 2a, 1 minus 3a. And to check this, you just have to multiply them out and see which ones are going to work. So here, foiling this out, I'm going to try to separate this stuff. So foiling this out, we have 2, and then minus 2a, minus 6a, and then plus 6a squared. And notice that the first and last terms should match what we initially had, because this process of trial and error, you're rigging it so it's guaranteed the first and last terms are going to match. It's just figuring out the middle terms is the questionable part, because we're getting two things that are going to combine together. But what would that simplify to? That would give us negative 8a, and that is not what we actually have here, right? So this is rejected, right? So we could just mark that right now that that's not correct. Simplify the next one. What do we get? So we have 2 and then minus 4a and then minus 3a and then plus 6a squared. Wow, that's really nice. It looks like that is the correct ones, right? So 2 minus 7a plus 6a squared. So that is what we wanted. So this is the correct factorization. So if you're in a hurry, you would just mark that as correct and box that. That's your factorization. If you're worried, you can continue on and reject the other ones. We shouldn't have any other solution. Okay, so what is this? So 2 minus 12a minus a, which would be minus 13a. That's not going to work. Plus 6a squared, and that's not correct. That's 2 minus 6a minus 2a, which would be minus 8a. Right, minus 6, minus 2, minus 8, so then plus 6a squared. So these last two are rejected, which is good, right? If they were accepted, that's not good. Okay, unless it was an equivalent factorization, but in this case it's not going to be. And that's it.